Hey folks, Chris with Microsoft here, aka Big Daddy Nines. Back with another Let's Tech. I'd alluded that we're going to do some network capture troubleshooting when we were doing the performance series, the network piece, and I never really got around to it. In fact, things got really crazy and I haven't got around to much of anything. So back again here today to kind of cover some of the network troubleshooting. Now, um, the reason that I wanted to do this is because there's a lot of folks out there that I run into that really they don't know how to do a packet capture. They know how to ping, and let's be honest, ping is not exactly a super duper really good utility for doing any. I mean, it's a good utility. Let me retract that. Say it's a perfectly fine UDP broadcast utility, but there are a lot more powerful tools in your tool bag. You just need to know how to use them. So if you already know how to use Wireshark or any of the packet capture utilities out there, then this is going to be old hat to you. So this isn't really for you. But let me just show you what we're going to do here. I've got a really simple little setup. We'll start up here on this top right area. So we've got a domain called Fabricam, which is behind a little pfSense firewall that I put together that keeps the 10.0.1.0 24-bit subnet separated from the 10.0.0.0, where I have another little setup. We've got a little Contoso DC sitting over there. So those are 24-bit subnets, meaning that these are segmented. The pfSense is acting as a firewall and a router. Right now it's kind of open both ways, just for us to get kind of kicked off here. Then everything's attached to a switch, which has an external firewall, which gets us out to the internet. So this is the Contoso DC that, as you can see, is in the 10.0.0 network. And it's over here on the right side. We've got the Fabricam.com. So Fabricam for Breakum, however that's pronounced, I'm not really even sure. Is on. I'm going to go ahead and flip off the firewalls here because we've got another firewall we're going to be using for testing, and I don't want to be having to configure two firewalls at once. You can see we've now turned that off. You can see this is 10.0.1.10, and just really quick, I can hop in the 10 dot into the firewall real quick and get logged into this and kind of show you we don't have much configured in the firewall right now. It's fairly straightforward at the moment. So let's just go to kind of the rules on the firewall. We've got two interfaces. We've got this LAN interface and the WAN. So WAN is the same network that Mr. Contoso over here is, and WAN is, or LAN is the network that the Fabricam DC is on. All right, so pretty simple setup. They all have access to the internet, and you'll also see really quick, just to show you how I've got that is, we'll just do a route print. As you can see right here, mark that. You can see I've just plugged in a static route for the 24-bit subnet so that any traffic going 10.0.1.0 is going to go through the 10.0.0.2.0.1, which is the public interface for this little firewall over here that we're looking at. And you can see that on the WAN interface, I currently said anything on the 10.0.0.0 network is going to be able to get to anything on the 10.0.1.0 24-bit network. So everything's open. It's all wide open. In other words, I can ping the other one from here. So 10.0.1.10, I think it was. Yeah, that's it. And theoretically, he should be able to go the other way too. So let's go and pull this up a command prompt. Ping 10.0.0. What is your IP address, Mr. Sir? It was like 202 or something like that. It is 202. 202. Yeah, so you can see we've got connectivity both ways. So I'm using ping, so this is all good stuff. But there are other utilities that are built in that I discussed in the the performance series. Go look up the network section. We covered things like path ping, and I think I even had some of the sysinternals utilities, which we're going to loop back to that one of these days, I promise. But you've got built-in utilities that are even better than ping that are in that. We're not using those today because this obviously doesn't tell you anything about the network itself. So what do? When we have a network communication failure between point A and point B, or point B and point A, just using ping doesn't necessarily tell you the whole picture. In fact, even using something like port query doesn't always tell you the whole picture. Yeah, the port might be open, but it may not be responding properly. As a matter of fact, I've probably solved more Active Directory issues just using NetMon than even getting in the event viewer, because sometimes what you get in the error message that pops up on the screen or what you're seeing in the event logs don't really give you the whole picture. But when I look into NetMon and I look at the packet, I might see an event from Kerberos saying this is not supported because of this weird obfuscated code. And then I look up that obfuscated code on Bing, and there it goes. It says, oh, well, you've got SMB signing turned on, or something weird like that. You see the error message that didn't really get you in there. So you can actually use NetMon for more than just troubleshooting network utilities. And you might be wondering, why aren't we using Message Analyzer? Well, frankly, because we're not using Network Analyzer or Message Analyzer because most people have already got NetMon installed on most of their systems. And if they don't, it's not a problem. I'm not saying you should do this or the other. The concepts you can use here would work for Wireshark. It's just going to be a little different using the command. So what I'm going to show you is how to set up packet filters and going beyond just the standard capture. So you can see we're just going to do a quick NetMon search on Google or Bing, and then click download, and it'll take you to this page. Obviously, for most of your servers, you're going to need the x64 version of it. And we'll go ahead and pull that down and get it installed. I've already taken the liberty of installing it here on Fabricam, and it's already up. But I wanted to kind of bring it down because I wanted to show you that there are, in fact, two things happening during the install, and that in the past has confused some folks. They'll get the first part of it installed and not the second. So what we're doing here is we're going to go ahead and launch the installer. You'll see that it's going to install the network monitor capture and the parser engines. You need both, and it actually kicks off two separate installs. It used to be two separate files, and you may still have that on your network. This is 3.4, but there was another 3.4 release that had both of the installers separate. You need to have the parsers, and that's really, in my opinion, where NetMon excels, especially when you're an Active Directory person like myself. If you do a lot of AD work and you need to be able to see what's going on, the built-in network parsers are great for being able to interpret what's going on. A lot of people, though, they get scared about using a network capture utility of any kind because they know a lot of stuff goes on the network, right? Oh, by the way, you saw me click Run as Administrator. That's another thing that doesn't automatically happen. So always click Run as Administrator, otherwise your captures will be empty. It's another reason people don't use it much. They launched it, they tried to data capture, and they got no data. So that's a problem. But they know that there's a lot of things happening on the network, and if you're capturing all of that, how are you going to read it? And even if it weren't for the fact that you're making a photocopy of a lot of the stuff going across your network, and you know that that's going to become a big ugly thing in a hurry, a lot of people, they don't know what to look for. Well, I'm going to show you just a few simple things, just like when you're analyzing a blue screen of death, right? Like 80 to 95% of the problems that you run into can be solved with some easy tricks. Any of the deep core analysis beyond that is obviously a little bit different, but for most of the stuff, just to be able to see what's going on, that's what we're going to be covering here today. All right, and finish the first part. You'll notice when you hit finish, it's automatically just going to start installing some more stuff. That's the parsers, right? So it's a two-piece deal. So while that installs, we're going to kind of look at the interface here. You'll see that it's got several different little adapters listed. You may have more of these if you have a multiple if you have multiple adapters on your system, you're going to see one of those for each. You also might see the ISA tap that's IPv6 tap, and so is the Torito. We're not going to worry about those at the moment because everything in this is just going to be IPv4 stuff. So we're going to click New Capture. That's kind of step one in getting all this going. I'm going to go ahead and slide this to the left right now because we're going to be setting up a capture with kind of some specific things. Note that there are two very important things on this screen right here. What you see up there is a display filter, but you'll also see capture settings, and you'll notice that there's a capture filter. All right, so let me explain the difference between those two. When you filter on the capture, you can filter only down to things that you want captured, whereas a display filter is inside of what you've captured. What do you actually want to see going on, right? So the built-in filters have little hints. So you've got a bunch of standard filters. If you can't remember what I'm showing you here today, then you can come back in there, but make sure that you're not trying to apply a display filter when what you're really wanting to do is apply a capture filter, right? To keep your capture from getting enormous and capturing everything that's going across the network, what you want to do is actually just, if you're having problems from point A to point B, then on point B you need to filter to point A, and on point A you need to filter to point B. That way you can see both sides of the equation and none of the other crap flying around on the network. So that's lesson one. That's really the biggest lesson that you're gonna need to be familiar with. So do that in your capture, and then if you got extra stuff you want to filter on later, like you only want to see DNS traffic or only Kerberos traffic, then put that in your display filter. Those things can be put in the capture filter as well if you know up front what you're doing. But let me just give you an example of a capture filter. First off, in here I can go ahead and turn off the adapters that I know that I don't care about. But here's a really simple filter. So we already knew from looking at this guy that his IP address is this 10.0.0.202. So I can do an IPv4.address. See, it's already populating, and I can enter to complete or tab to complete. And then NetMon likes two equal signs. When you're going to do that, we're not going to get into why until later, but it's an actual equation. You can do not equal to and things like that, and that's why there's two equals. But just remember, IPv4.address equals equals. This is the most common thing you're going to use right there. Take a look at it, right? And then, not surprisingly, you put in the address, 10.0.202. There we go, just like that. And it's just as easy if you're looking at multiple things. Say you've got 3 DCs on this Contoso side over here, and you've got this one Fabricam DC over here that's not functioning properly. I probably just put my hands on the wrong side of the screen for what's actually above me here. But you can just say, or IPv4.address. This is a perfectly valid capture filter, O.203. There you go. That's it. Now, here's the thing everybody forgets. That a button right there, apply. You must apply your filter before you close it, or it will not be filtering anything, right? And if you want to change it on the fly, you can do that by changing it and hitting apply again while the capture is actually running. It'll change it right in line. When I click close and I click start, all that is going to happen now is that network adapter is going to be filtered and look for only packets that come from this other person. Now, earlier I had mentioned point A to point B and point B to point A. It always matters. It is always urgent and important that you except in situations where there's just no way to do it, at all times one must always capture from both sides. Now you can tell that the capture just started. You saw it just popped up 2 lines. That's what you're waiting for. Sometimes on slower systems, NetMon takes a few seconds to initialize. Once you see your filter in place, that means you're good to go. It is now looking online, and you'll notice that it has actually, sitting there monitoring stuff online, and I could on this system go to very slowly go places. Wow, that's spectacularly slow. Come on, little guy, hit me with another tab. I probably set all these up with a single processor core and now have denial of service myself. So what I was going to show you was if I go someplace like Google or Bing.com, obviously I am now generating network traffic, and you would expect to see a lot of that coming in network capture. But if I minimize this, you'll see there's nothing. There's nothing because we filtered to it, right? But on the other hand, if I ping this guy 10.0.1.10, I think it was, you'll see ICMP traffic just hit. So now we have a whole bunch of pending packets kind of fluctuating up. It's dropping those out because we put the capture filter on it, right? Now this is where a display filter might be important. You can actually do those right in line. I could say add the source to the display filter and apply it. Now all I'm going to see is stuff coming from the source Fabricam, right? So now I'm only looking at those 4 packets, and then it's just as easy to remove those. So they're still in the capture that we had. Okay, back to my point before the tab freaked out. You should always capture both sides. The reason I say that is because I don't know how many times I have been looking at a network capture, and seeing the weirdest of behavior, only to finally remember, oh yes, NetMon instructor from 15 years ago told me always capture both sides, and I go capture the other side, and lo and behold, the other side is not seeing any traffic. I'm seeing strange stuff happening on this one server, the other side's not seeing it. What does that tell me? I'm not actually talking to that other side. And that actually happens. You know, you get firewalls that'll intercept port 80 traffic, and you don't even know what's happening, but it looks like you're talking on port 80 to something out there, but what you're not doing is talking to where you thought you were, and then you don't see any traffic coming from the other side. All right, so again, whenever you're going to launch NetMon, you need to run it as administrator, and you don't need to keep checking for updates since NetMon has been kind of deprecated. Do a new capture, and so on this side, obviously, for anything we're going to try, we're going to do the IPv4.address equals that other guy, 10.0.1.10. There we go. And I don't need any of the IPv6 on there, so now I've got that one on. And I hit close. Okay, so pretty straightforward. Anything we do between these 2 servers right now is going to go into the capture. Another little trick right here. Let's fill that up a little bit. This little button right here, this one that says auto scroll, that's a good thing to have, right? So now you can see it as it's going. So I know it should be obvious, but for, I don't know, a year, I always used to say, gosh, I wish that NetMon had an auto scroll. It was up there the whole time. I just never noticed it. Big blue button. So anyway, hey, look, use the auto scroll. It's cool. That'll keep the latest packet going. And when you're monitoring for things going on, things hopefully more interesting than ICMP traffic, you can see actually the motion of it going. All right, so let's kill that for a second. Now, what we want to do is we want to kind of go through some ideas of why we would expect to see something useful. This just looks like a whole bunch of just nonsense to most people. And, well, frankly, it kind of does look like that, but there's some obviously recognizable bits that are going on in here. So before we start digging into what you might expect to see during a failure, which we're going to set up a failure and we're going to look at what that might appear to be by changing some of the firewall rules on that pfSense that we have running here. So we're going to get in here and mess with that a little bit, but let's talk about the different components of what we're seeing here. First of all, this tab over here where it says all traffic, my traffic, unknown, if you're looking on everything that is going on that box and you just want to filter it out and just look at certain pieces and parts of traffic, this can be useful, but for just troubleshooting a point-to-point, I usually just turn that tab off. Give myself some real estate here in the capture window. Obviously, the buttons up here are for starting and stopping the capture, and the capture settings, we need to keep those going. This is the start page we were at. These are a bunch of parsers that are built into NetMon. That's your actual capture, and if you're running multiple, these are the tabs you use there. display filters below that, and then below that is the actual frames. All right, so inside of these columns, these are just incremental frame numbers. You know, they go up every time it catches a new frame. This is the time, time offset since the last one. Process name, that'll appear sometimes, and sometimes it won't. Like if you're in the DNS console and you're doing some tests, it might actually say mmc.exe or DNS mgmt, depending on how you launched it. It might be DSA or the Active Directory services. So whatever it's running from a process, sometimes that can be useful. But we move over, then we've got source and destination. Now, source and destination, it will attempt to actually look up the DNS address of what you're getting, so it'll get you a pretty friendly name. That is not always terribly helpful if you are looking at multiple machines, but if you're just looking back and forth between these two, if you want, you can actually change the source and the destination up here in columns. The other thing that I find useful a lot of times is it tries to tell you protocol name right here, and it tries to tell you kind of what port you're talking on over in this description area, which is actually an actual breakdown of what's in the header of that packet, which we won't go into a lot of details here because that's getting outside of that 80 to 95% bit. We'll cover a little bit maybe, but not everything. In the columns you can actually add stuff. So one of the most important ones that I find myself is like destination port right here. I will a lot of times put the destination port right next to the destination because gosh, that comes in really handy when you have multiple ports going on. So you can also get in here and to add in the source port. I'll usually take the source port and move it right next to source, like so. There. And so now we can see we have not updated the screen for whatever reason. Oh, it's spinning blue done it. Trying to add that in. There we go. See, now I've got more stuff in my capture window. Yay, more things to look at. All right, so there are no ports right now because everything we've been doing is UDP, because ping does not actually produce a port. It's just a broadcast, right? But if so I was hitting this guy on port 80 or something, then we would see some ephemeral port range stuff on one side and 80 on the other. Over here on the far right is the conversation ID. This can be helpful because typically what you're going to see, and we'll cover this in a second, is a SYN, a SYNAC, and an ACK. We'll look at what those look like, but that's hi, and the other guy's saying, I hear you saying hi. And he says, oh, I hear you saying hi that you said hi, and so forth. It's a handshake, a three-way handshake, and during that, they kind of decide on a port and some other things like that. Anyway, it can get convoluted. Lots of different pieces flying around during different conversations. It's nice to know what conversation ID you're talking to. The ID of the conversation, if it's mixed up with a whole bunch of other stuff happening at the same time, this can help to kind of clear that up. You can even sort by it, but not while the capture's actually running. Okay, and then again down below, this is what was in that traffic. In this case, very simple echo reply message. Boom, okay? And you can see A, B, C, D, E, F, G, M, Q, F, G, H, I, right? So it actually, inside the ICMP bits, it threw in some letters and stuff, right? So you can actually see that's what went across the network. Inside the packet, when, when it goes out and it says, hey, the bytes equals 32, well, that's how it got 32 bytes. It started throwing alphabet characters at it. So there you are. Okay, so now we've got captures running between these two servers, right? And mostly happy traffic at the moment. So we might do some stuff to generate something other than ICMP traffic, and then let's break some of that stuff. All right, so we're already capturing, we're already good, we already know that the network's up. We have two different forests, so I guess let's create a trust between them. So let's go to domains and trusts. We'll do that on this Contoso side, and so we'll go to properties, and this should generate a whole bunch of AD traffic here. So we're going to go ahead and do, I don't know if he actually can, I bet he can't resolve. We may need to do a quick forward lookup zone on both sides, actually. So Let's do NL test, DS get DC, Contoso. Wait, am I on? I'm on Contoso, aren't I? I'm going to get these mixed up every time. You know, he can find Contoso just fine. Fabricam.com. Yeah, no such domain. And you would notice, no, I did an NL test, which should do a quick little bindish thing to the other DC if it knew where it was. No traffic happened here. He never attempted to look that up. All right, so sorry, I should have already had this set up, but let's just fix this problem real fast. Okay, we'll do this real fast by building a conditional forwarder. We'll call it fabricam.com, and we'll pop in the address of the other DC, .0.1.10. Was it 10? Yeah, so okay, we saw the traffic. Look, we saw port 53. Now, you'll see the source port here. You'll notice that it said DNS because it's actually the DNS console on the other system talking to DNS on this side. So those are processes talking, so now we actually have something interesting to look at, right? On the source port, 58979. So that's an ephemeral port. Right, so those ephemeral literally means something that's there for a little while and then gone. The ephemeral port range is 49,000 up through 65,000, 535. They're just quick use ports that Windows will use, but we know DNS uses port 53, and so you'll notice that the destination port, the port that it was going to go talk to on the other side, was 53 here on this side. And then we replied back, coming from 53, going to that ephemeral port. Right? Now it said it was unable to resolve that port, but I betcha it actually can, and it's just being a butthead about it. We're also going to store this in AD in case later we decide to add some more. So we'll say everybody in the forest gets a copy of that forwarder, and then when I go into Fabricam and I look at that, I should be able to do this now. DS get DC, still no love for you, and S lookup fabricam.com. Okay, so it found it. You saw here we had some more DNS traffic. You see that the source, again, we were looking for a DC, so we did a DNS query. So now we've gone from boring old UDP ICMP traffic to something a little more interesting on DNS. So we've got some stuff flying back and forth on port 53 looking for something. And if we go down to here, query ID, response success. So you can see in the far right over here, that's what it looked for. So the way this conversation started, and again, we're looking at the conversation ID, is now 16. So we see that this is a new conversation. We have come from that other address over here to us, ephemeral port to port 53. What did I say? I said query for fabricam.com. And that's what it looked like over here in the machine language-ish type of stuff. So we had a reply and we had a success. All right? If we dug down in a little bit further, you can see here was the Fabricam IPv6 address and other information. You can see we had a nice, pretty little conversation without even having to have a three-way handshake. So that was just capturing a quick DNS query. That's as basic as it gets on capturing this stuff. Now, why it won't actually do a DS get DC for it, I don't know. It's never making it over here to the other side, so I'm not really sure why he's doing that. It could be that he'd cached that he couldn't find it before. But without that working, we probably won't be able to create the trust. We can give it a shot, but since it also might just mean that we're timing out something funky that happened, we know pretty much for sure that we're going to need to go back the other direction. So we can go really quick and set that up going this way. So we'll say DNS on him to and why did it go to that? Let's go to DNS. This is definitely a server that I didn't set up with enough power. So we're going to fix that next time we have to reboot this guy. Give him perhaps a little more power, which I can't do on the fly, sadly. This is my 2016 box. Oh, and by the way, I didn't mention before that the server on your left, there's obviously a 2012 box, so the other one is the new 2016. Yep, one virtual processor. Yeah, we need to give him more powers, because that's going to stink. It's going to make everything really super slow. All right, so we got Fabricam DC1. We're going to go into conditional forwarders. We're going to build us a new one, and we're going to point it back to Contoso. .com, and you are going to be 10.0.0.120 something or other, 220. I have no idea. Why I can't keep that straight in my head is beyond me. But that's why we have cheat sheets. 10.0.0.202. 10.0.0.202. All right, there we go. We should actually be seeing some decent network monitor traffic going back there. It's already happened. It's just not showing up in the deal. All right, so we're going to store it in the forest. We're going to click OK, and yay, there we go. So we've got DNS going both directions now. And we saw the conversation hit. So it was another little boring conversation inside of NetMon in this case, but there you are. Auto scroll, you can see, hey, he knows what both names are. Why would that have changed all of a sudden to Fabricam and Contoso? Well, easy. We have name resolution. We know that's working now. Alrighty. Still no such domain. I wonder if we can get the other direction, because I am really pretty sure dsget dc contoso.com works just fine going this way, albeit slowly. Oh my god, it looks like a teletype. Look at this. Oh, this server needs another core badly. All right, so there. So we got some interesting stuff doing. We even had some LDAP message stuff. So that's a UDP version of LDAP happening there. So obviously, you know, port 389 on your LDAPs is right. Well, this is 389, but it's a, as you can see, LDAP message, which was a UDP broadcast of that. So sometimes you'll see UDP versus TDCP in the protocol name, but since the parser's on, it actually knows what kind that was, and so it puts that in there. So a little bit of geek trivia there for you. All right, so we've got it going this way. I've probably done something stupid on this side that's keeping it from being able to do that. Fabrikam. FAB, maybe I have it just Fabrikam. Fabrikam looks right to me. Why you don't want to go and resolve the names, my little guy? Fabrikam. I didn't mean to ping you, silly guy. All right. Let's try it again. But this time we're going to repNetMon and bind to Fabrikam.com. All right. Yes, we can bind. But we have a DNS problem with it, preventing it from actually doing that. So here we just, by binding, we just created some really interesting traffic. We'll fix the DNS thing in a little bit, but we're going to turn off auto scroll and let's look at what we just had happen here. Since we went out of some of this boring world and got into a little bit more of a typical kind of a conversation that you see. Right over here where it says S, that means SYN, and AS means SYNAC. That's the hi, and the other side saying, oh, I hear you saying hi. And this is it coming back again and saying, I hear you here saying me that we said hi. Something like that. Let's look at it on this side because it's more, well, I was going to say it's great because it's got the DNS resolution. So no, it doesn't. Let's just stick to this side since we're already looking at it. And then we send back and forth some LDAP messages. So this is a typical kind of healthy conversation between two servers, right? We could go and look and see what they were saying, but most of that is not going to be terribly usable to us. And I have got, yeah, since it's LDAP message, it's not going to be anything really usable, but what you're looking for is, are they talking? Do we see anything in here that would indicate that one of the servers does not like talking to the other server or is doing what we will call a retransmit on one of the ports. We're going to get to that in a little bit. And it's the biggest thing you're looking for is out here is, do we have this server talking to that server, but that server not ever answering back? Well, we do. We do see them talking back and forth. When this server talks to that server and doesn't get anything back, that's when you'll start seeing repetitive conversations, and out here in the description you'll start seeing something called a retransmit. That means I was able to talk to you at one time, but you're gone. Where did you go? Hello, 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 and then fail. Usually at least 3 retransmits, sometimes more. Some applications never give up and they'll just retransmit forever. But there's one right there. For one reason or another, not sure what it might have been, this server from conversation 187, when he sent his ACK, he didn't get anything back. ACK back. Didn't get my ACK back. Okay, God, I should not be trying to be funny. So he tried it again, right? So he retransmitted the ACK, and that happened right here, not right there, 187. Sorry. Isn't that a code for, like, homicide? I don't know. So he resent that. So when you get a bunch of retransmits in a row, especially when they are on a specific port, and in this case this was 389, if we see a whole bunch of those, you know you might have a problem. And here's another one right here. It's just another little port push on that. So that could be that I'm overwhelming my firewall, or this poor server, which was hung up in La La Land there for a bit, much more likely, with its one little processor core. It's literally less powerful than my phone at this point. Got hung up. It had 100% processor utilization and didn't respond back, and so the other guy retransmitted. So send, SYNAC, ACK. Now these are very interesting to go track. When you have a latency problem, you'll get retransmits. These aren't indicative of a big problem, but these do happen. But when you get a bunch of them, that's when you know you're on to something, right? So I'll show you an example of that in a moment. But here is another time where we would use the display filter, right? So I don't want to lose this whole capture. And I've already captured it, so it doesn't matter anyway. But I want to see anytime we saw some of those retransmits and where they were coming from and on what port were they happening. So, so if I can remember, this is a property. If we spell it right, it works even better. Property.tcp retransmit, like that. There's another one that you'll use sometimes called a TCP SYN retransmit. It depends on if it happened at the beginning of the conversation, and especially if it's something like a port 80 type deal. So if I apply that display filter, now what it's going to do is take its one little bitty processor core and go through that list and go find out all the times during that capture that we had this. You can see it happened at 3 different times during the 187 conversation, during the 190 conversation, and during the 192. In all 3 cases, it was 0.202, the other guy, trying to talk to us, and in all 3 times it was him retransmitting those packets. So if I go over here and I do a property .tcp retransmit, not read, are you serious right now? Really? You don't want to do anymore, do you? retransm. It's because it's a TCP retransmit. There we go. All right, so when I apply that to this side of the conversation, what we'll see is kind of the opposite, right? The source is now the Contoso side, and in fact, we're talking to him on port. Where is it? I don't have the port deal. So if you haven't turned on your destination, your source port, they're right here. I'm hoping that the mouse is showing up right, but you can see the source port. You can see that it was 389 twice, and then endpoint resolution 135 twice, and then a port 80, actually. So he saw what this guy saw, so it was pretty much lined up. just means that he tried to talk to him, but he wasn't answering, probably again because processors are bound up right at that time, and so it just continued to see a non-responsive behavior within the time that it was expecting to see it come back, right? So anyway, you can see it with or without the port. And the reason I have it in here and I have it in as a column there is, for me, when you get into these deep, thick captures, sometimes it really helps. Plus, you can actually do copy source port to the display filter, and then you would only be looking at, let's say, destination port being port 389. So that's a good reason to have that as well. The other one is the TCP SYN. Oh, it's not going to autocomplete. SYN retransmit. So this would be a good time to have both. Like that. So now we have a filter with two different things that we're looking for. And apply it. Now, of course, we didn't have any send retransmit, so that's not actually going to show up with anything usable right now. But yeah, so there's two hugely powerful tools you can use for those types of issues. All right, so let's clear off our filters, the display filters. Let's leave the captures running. Let's run another test here. And it was just being a pain. It was just taking a little while. It didn't want to work right then. All right, so we've got name resolution on both sides of these. So they both know how to find each other. They both know how to do things like look each other up. So we should be able to get through a trust wizard at this point. So we are on Contoso. And there we go. Lots and lots of syn, synax. The other piece you see is an R. That's a reset. Syn, synac, ac, they talk, and then they reset when the port is done. What that is, it is an indication to the other server that you can release that ephemeral port now. I'm done with it. And it goes back into the time wait, and it stays there for a little bit, and then it becomes an available port again. Usually what you'll see before the reset, which I didn't see any of in here, is a fin. So syn, synac, ac, payload data. In this case, you can see we had SMB2 stuff. We had just general TCP over 445, which AD does use that. It doesn't just use 445 for file transfers. It does actually use it for authentication stuff sometimes. So anyway, when he was doing a whole lot of little queries against him, some of the things were like, okay, what is your NetBIOS name? What are the other bits and pieces of information that you do, the LSA RPC, for instance. It needs to be able to query that so that I can actually see, hey, are you something I can trust? And then it answers back. As long as you don't have a STIG on that server, it will allow it to answer at least a basic minimum piece of question. It's just anonymously asking you, are you something I can trust? And it comes back and says, I am something I can trust, and my name is this. And it's like, good, okay, well, that's what I was hoping your name was. All right, so we're going to switch this over to Forest Trust so we see more Kerberos than we do NTLM type stuff. We'll just do a two-way trust. Why not? That's fine. And since we know the other side, we'll go ahead and create this on both sides. So the other side is Contoso, and it's just got administrator right at the moment. And put the password in, and then we'll wait for it to do things. We actually should see quite a bit of stuff happening over here as these guys negotiate. Oh, I forgot my auto scroll. There were lots of things happening. We just missed them all because reasons. All right, so you'll see that now we have some LDAP SAL. We've got let me turn off the auto scroll for a second. We've got MSRPC. We've got some more SMB stuff. We've got some buffer stuff, but a whole lot of communicating on port 389, port Well, it was mostly port 389 and 445. I was expecting to see possibly some 88 in there since I did authenticate. I bet if I went up high enough, I probably do get to see some of that. I'm not spotting it, so what do? Maybe what we do is we go tcp.port equals 88 and apply that and see if we had any Kerberos traffic anywhere. I didn't say source port and I didn't say destination port. I just said any Kerberos port. Evidently, we didn't need that, even though I did give it a username and password. But just to show you that that display filter will work, we'll go ahead and show it on 445 so you can see now all of the 445 communication there. So this is kind of lesson number 3, tcp.port. You can do it on source port, you can do it on destination port. You can even combine these. So we could even say or property .tcp retransmit and apply that, and it'll say, hey, either stuff on 445 or retransmits. You can see you can mix and match these pretty good. So a lot of cool stuff you can do there. All right, so we've got that removed. We need the auto scroll on. Let's go ahead and continue through this forest-wide authentication. That just means that we're not doing SID filtering. We won't want to go turn that on for right now because we're not doing a trust video. We're just doing a port type stuff. Okay, so there was a reset. There's the fin. So I was going to say before, and then I got distracted. Send, SYNAC, ACK, payloads of data, and then when it's done, you'll usually see a fin. The other one will acknowledge the fin, and then you'll see the reset. Why are we doing keep alives? Are you not? I thought, oh, I was expecting that I had clicked next and we were now spinning donut. See, this was an indication to me that it was waiting on me for something. So I thought that this actually was stuck. So we're going to do forest wide, not selective auth. We're going to say next, next, and finish. And I wouldn't be too shocked to find that we do finally get some Kerberos up in there since we had a password. But I guess that's probably going to be NetBIOS that just died. Oh, okay, there it is. Okay, do I want to confirm it? Yes, we do. No. All right, let's confirm the incoming trust. And we are seeing lots of good stuff happening, and it finished. All right, so we reopen the dialog box and go check it out. So first and foremost, we need to go and look at the name suffix route and make sure that it knows it does, so we're good. That's always something you want to check inside your trusts is, do we have a name suffix route to know how to get to the other domain? And we do, so we're good. Okay, there we are. All right, so we've got a trust. We can now do authentication-y kind of stuff between these two forests, and I did that rather than doing a full-on just domain across two different subnets because I want to be able to restrict the ports, and authentication across a trust is actually only a handful of different ports compared to the entire 80 range. So now we're going to do is we're going to start squishing things. So the first thing we're going to squish is we're going to try to get, you know what the first thing is we're going to do is I'm going to pause recording this video and I'm going to shut this DC down and I'm going to give it more processing power and then I'm going to bring it back up. All right, it's back up and running again. Took a little while. It didn't want to shut down proper, and so now that it's back up, got a little more juice on it. All right, so what we're going to do is we're going to take the firewall rule here, which is allow anything from the 10.0.0 network to the 10.0.1.0 network, and we're going to constrain that a bit. So I'm going to get in here and I'm going to remove this rule, and I'm going to put some replacement rules in. And actually what we'll do is before we put the replacement rule in, we'll go ahead and disable this just to generate kind of some standard retransmit type activity over here. So let's just do some really simple stuff rep admin bind. That is going to work because I didn't apply the changes on the firewall. And this should, if I got it in time, should cause it to fail. And if it ever actually makes any attempt whatsoever, then we'll actually start seeing some retransmits happen. But at the moment, I don't know. Okay, server down. All right, what did we see? We have nothing pending. We didn't see a single retransmit, and I don't know why. We should have seen actually several attempts. Am I running here? And is that currently? Oh, that's why. Still had that display filter applied. All right, or maybe not, because keep live reset. Let's try this little doohickey again. Let's try to bind to fabricum.com and see if we get any traffic going. I can guarantee that on this side we won't have any traffic past the last couple seconds, just because, well, we shut off the firewall rule that allows it. So I would think that we would be seeing at least, oh, you know why? Because it's trying to relook up the server, and it's doing a DNS query, and the DNS query is failing. So it doesn't even attempt to do anything else. So let's be fun here. Let's cheat. 1.10. All right. So now we've got an LDAP and a retransmit. So we're saying send. And now we see the other kind that I told you about, the send retransmit. So we never actually had a good conversation, so we're trying to resend the send. And he's saying hello, and hello, and hello, and server down. So this is pretty much a right out of the bat send retransmits because we don't have anything. But that's not how these usually go, right? Normally, somebody screwed some rule up somewhere on some firewall. And some things work and some things don't. This is why sometimes pings work and you still can't get across, which is why port query can be very handy. But if you want to know specifically what's going on the wire, this is a good thing. All right, we never saw anything on the other side, and we wouldn't have expected to. So I'm going to load up some rules here that should be kind of the bare minimums to be able to have stuff work across the trust. And I'll pause the video so you don't have to sit here and watch me adding rules into a firewall, because I'm pretty sure you've all done that before. I'll pause the video and be right back. All right, I've got them loaded up. Okay, so we've got several different ports you can see in here. So let me cover a few of these. Now, this isn't the typical what you would see as like requirements for AD in the big article, right? It lists a bunch of Swiss cheese holes in the firewall. Not all of those are necessary for maintaining a trust, but you know, some of the biggies, obviously, like Kerberos, and you've got LDAP, and you've got the endpoint mapper, which we'll be covering in a second, and the ephemeral range, which also becomes important here. So anyway, everything is still working the way it was before. Just now we've kind of pared that down to a few different rules. But let's say that the endpoint mapper was working for RPC communications, which is basically going to come down to CB radio communications is one way, I guess. Everybody sits on channel 18. I know this is really, really out-of-date stuff, but if two people wanted to talk, they would say, you know, go to 43 or something like that, right? And then they'd chat on 43, and then they'd say clear to 18, and they go back. Basically, you talk on one open channel to go and find what channel you're going to go to. The way two computers, when they're going to do RPC communications, is they're going to start on port 135. They're going to answer on the other side with an RPC request in the ephemeral range. And as you can see here in the capture, it's 49,152 through 65,535. They're ephemeral, they disappear quickly. The entire purpose of those ports is to do an exchange, to do a bit of communication, and then when it's finished, those ports get closed. People very frequently will go close these because there's so many of them, and it's scary. They're like, well, why do we have to have all of those ports open? So let's do what many network administrators sometimes do and shut that down and say, I don't think we really need it. What are all those ports for? So now we're gonna do another little bind exercise here. So binding to Fabricam should now be broken. And we'll go ahead and kick up a capture to kind of look at that a little bit. And we'll wait for it to fail here. And when it does, we'll kind of analyze what's going on. And I don't know if I got the capture started in enough time to really make that anything usable. So let's do this again. We're gonna clear off this capture and start it again, and then we're going to wait for that capture to start. And for some reason, even though I gave it more processors, that one's still running a little slower than the other. But as soon as we get the little indicator that that is running, then we'll go ahead with it. Ready, go, big guy. Come on, show me you know how to network. All right, we'll pause the video since this thing's going to take 45 minutes to start its network cap. Okay, it was more like 2 minutes, but all right, so that's going. So we're gonna hit this again, and you'll see that there's a lot of communication going here. So this is a condition where we did actually get some ports open, but not others, and now we need to find out which ones those are. So now we're going to look at the actual traffic. We can already tell that it's failed, and we can also see some transmits. The transmits have now stopped, and it's gone ahead and sent a port reset. So it's going to talk about one of the big things that were going on here. Let me turn off auto scroll and stop that capture for just a second. Okay, so when it comes to endpoint mapper, so you can see that we're, once again, just to kind of reset, we are Contoso, and the Contoso DC is going to attempt to talk to the Fabricam DC on RPC. You can see that's MS RPC communications. So what we'll do is we'll hit it from one of our ephemeral ports on port 135. That's the breaker 19 channel. That's the, hey, what port are we going to talk on it? It's going to give you a bind ACK, and then you're going to send it a endpoint mapper request, and then you'll get back a response. And all of those things worked. Everything worked just fine. Inside of the endpoint mapper response, it'll tell this computer what port to talk to it on next. So you can see it reaches out, and it tries to talk, in this case, on 670, and it sends a SYN. And then as part of a different communication, it actually acknowledges the that it got that port. But then on this, you can see that it is attempting again to retransmit on that port. And again, nothing opened up, so it eventually gives up and it resets. So you can see we had some Kerberos stuff, we had several different things that were working just fine here, and then all of a sudden we kind of hit a brick wall. The reason for that is because the ephemeral range is closed. So that's a good indication to you when you see it in that that range. Once again, the 49,152 up through the 65,535 was closed in this case. And different ports do different weird things depending on what it is that is the task that you're attempting to accomplish. So it's not always a matter of just endpoint mapper stuff. And actually, it occurs to me that we have, why is that not enabling that rule? We need to turn that back on. There we go, and turn that on there. We may need to change the type of trust really quickly so that we can show some additional weird behavior that you get when some ports are open or some points are closed. But the main point, if you've gotten this far, this is the type of thing you're looking for. You need to know kind of what ports are communicating, and even in some cases what applications, so that you can kind of pare down Where is it broken? Sometimes what you'll see is something's taking an incredibly long time, but it still works. And if you're doing a NetMon capture, what you might find is that it's trying 3 or 4 times in a traditional way, and then it has a fallback method that it'll eventually drop out of. In this case, RPC is going to be just RPC, but there are other times when that's not necessarily the case. So anyway, let me set a couple of other little things up, and I'll show you a couple more examples. I'll pause the video. Okay, as you can see, I have disabled 389 standard LDAP. We've still got all the other ports, including global catalog, secure LDAP, and all of that stuff. I've got a little group here, and I have a member in that group. And when I look in here, I can see that user object from the other domain. So that's been created, but if I try to add, actually let me just try removing that person from the group, and then let's go back and re-add him. I just saw him, he was just there, but when I try to go in and try to add that person to the other domain, even though I was able to query that before, I find that we start shooting these LDAP messages across and they're failing. So these are sort of like send retransmits, but they're not, because what we're looking at when we see that, there's the retransmits right there. The LDAP messages, that is the same as a UDP version of LDAP. I think I'd mentioned that earlier. So you'll see the LDAP message a lot when a client computer is first trying to find domain controllers. It'll send out kind of a broadcast and see who responds back, and a lot of times that's how it determines which domain controllers are online. A little bit further down here, you can see that it just kept on throwing LDAP traffic at the other server, but it wasn't able to get that through. So this is one of those weird conditions where we could view users from another domain, we could manage that, but we can't actually do anything as far as adding new ones, because that one particular port is not open. So when we tried to hit the query, when the initial piece, and see if I caught that or not, when I opened it up, I'm not sure if I was running the capture. Yeah, I was. Okay, so when we first started this capture, that's where it actually found the Chris object from the other domain, because that was RPC communications, viewing that name. Now, I understand that that object is actually a foreign security principal, but that's fine. It doesn't have the identity information from this foreign security principal. The name Chris would only come up as a bunch of GUIDs if we didn't have that working. It would still see that it was there, but the foreign security principal would come up. But this right here, this RPC communication, which did work, actually showed us the Chris object, but when we removed it and tried to add it back in, it switched over to an LDAP transaction, and we've got LDAP shut down. So that's why that second part of this started to fail. When the reason I had to switch the trust type actually was because I needed to go to an external trust, because otherwise, instead of using LDAP, it would have been using SLDAP instead, and it also uses port 445 and some other things. So I thought it'd be more interesting to shut it off like that. So let's turn LDAP back on and re-add the Chris object. So now we should be able to go in and check the name and the LDAP transaction. We need to probably have the capture running. Should have started a new one more than likely. I'm not sure if we let the router have enough time to do its thing. Yeah, I don't know that I got that enabled. Still showing disabled here. That needs to be enabled. Apply the changes. Let the little process on the router reboot. And let's try again. Should be working actually any second, because it is retransmitting on 389, and we just turned 389 back on. Of course, it's in the middle of a communication that failed, so it doesn't know about the other side. Yep, and it failed. So let's go ahead and click it again, and now it works. So now we've got this Chris from Fabricum added back into the group. But let's turn off the RPC communications. This is so funny. Disable. There we go. Apply changes. All right. So now we have no RPCage. So let's stop and restart that. And it's going. So let's go back into our little group. And now this time when we go over to the Members tab, you'll see that it's doing what I was mentioning before, which is it's attempting, even though it is a foreign security principle and it does actually exist in this directory, it does have to go out and resolve that name. So you can see right here, we are retransmitting, trying to get back a hold of that other domain controller. And it takes forever. I've actually seen this work, believe it or not. Sometimes it'll try several times on an RPC communication and it'll actually fail back to another protocol. Not just in looking up users, but other functions that Active Directory does. Active Directory will sometimes piggyback communications on other ports. You'll see it sometimes try an LDAP transaction and then move to LDAP. You'll sometimes see things that should have been on probably other ports wind up on port 445. I think I mentioned that earlier, actually. Anyway, this is about to fail when it does finally give up. And the reason it's taking an incredibly long time to fail instead of just failing instantly is because the DC knows that it's talking to the other DC. It's getting that communication between it, it's getting handshakes, but then when it tries to go to the endpoint mapper, it's totally confused. And so now we close the communication and it goes back in and it tries to move to SMB. This is what I was mentioning before. But anyway, it's rolling through several different protocols trying to do things. It's confused because it can talk to the other server. It has a token with the other server. It's done DNS queries to look and see if maybe it needs to talk to another DC. That hasn't worked. It is still sitting here timing out, waiting to please go find the members, which you've probably seen this, and now it's given up. It has finally said, I can't show you the friendly name of this object. I know what this thing is. This is actually an object in the local directory, and that GUID would match this, but it's a foreign security principle, but it couldn't match it to the name because that one port that it wanted to talk to wasn't being answered by the other domain controller. So it took it forever, finally failed. And like I had mentioned, there are some times when you will see things actually succeed. You know, this wasn't really a success, but there's other times when they'll do that, and sometimes that's when you want to get in and do a little bit of a NetMon trace and see if you can figure out maybe what's going on under the hood there. So yeah, anyway, there's a good couple of examples for how you can go about setting up your NetMon traces for both sides of the communications, doing some port filtering, some display filtering, some filtering for send retransmits and TCP retransmits and LDAP messages, which are effectively the same type of thing, UDP type of broadcast, hey, find me a domain controller, and what it looks like when you need several ports open and maybe only one of them didn't get open properly by the network team. Anyway, I hope this has been informative. I hope you've enjoyed this. This is part of a series called Let's Tech, and if this is the first one of these you've seen, I have a number of other similar type of videos where we just kind of go through and talk about tools that you can use, technologies that are out there in the Microsoft stack that are part of your tool belt or part of your, a lot of times these are troubleshooting related. So if you want to go check out the playlist for that, the link is in the description, and if if you did find this informative, I sure would appreciate a like, and if you want to see more videos or know when I upload new videos, hit that subscription, maybe even consider hitting the bell so you get notified, and otherwise, thanks for watching. Hope you guys have a good one. See you next time.